Welcome to video 43, Domain and Range of Functions. Here are our learning targets. I can determine the domain of a function and I can determine the range of a function. Those are some new words for us and they're synonyms for some things we know. So hopefully some things will click here for you. Thanks for listening carefully and just writing down a few things along with me. Let's first talk about you. Let's think of this scenario and write this down. A dream job here. For every hour I work, I earn $26. Go ahead and write that down. Think about what kind of job you'd like to do. Any kind of job at all. Dog walking, making donuts, knitting caps, playing baseball on a team. I don't know. Anything at all. All right. Coaching, something. All right. You earn that much. All right. And so let's write an equation. Y equals, go ahead and write it down. And you already know this. It's $26 an hour, and so it's 26x, right? We've been doing that all year. The rate goes next to the x, right? But a lot of times we write equations that don't have any meaning or context. Now we are looking, when we talk about functions, they have relationships and they have context. So this is going to be a function, all right? And so we're going to write it like this. So write this down for me. The function of x, or your hours, is equal to 26 times however many hours you work. And so writing it this way kind of lets people know that there's a relationship and that it's based on whatever x is. And x is the independent variable, and it's what you start with, right? So let's say you work 12 hours, maybe 2 6-hour days, maybe 4 3-hour shifts. You work 12 hours let's say this week, all right? And if I calculate that for you, so let's write that in function notation. The function of your work based on 12 hours, and I'll calculate it for you, don't pick up your calculator, is $312. What? That is fabulous, okay? And so this is called function notation because it's showing us a relationship and it's showing us the two numbers involved. And consequently, that is the x and the y values that we look in our table at when we put the equation in our calculator. All right, so our domain is the input. It's those hours, any amount of hours you put in, all right, to the relationship to calculate it. And so for every input, there is an output. So let's say, here it is. Highlight independent values, and they're the x values, like I mentioned before. And then I added the word calculated because that helps. That it's when I input something, there's an output, and a lot of times we calculate it. There's a relationship, all right? So we need that input to be able to make a calculation. We also just look at the x values in a situation because that tells us the beginnings, and we also look at things based on the situation. All right, look at those x values. So let's write just 3 points. If you don't work any hours, you don't get any money. And so the domain would be 0 hours. We use that to calculate. Let's say you work 10 hours. You make $260. The 10 is the input or the domain. All right, and let's say you work that 12 hours that we already calculated. That's the input. Your output or your range then is 312, which leads us right to using a new vocabulary word for the y values, which is the output of a situation. All right, so that means that they're the values that were created by the input. So when I put my hours in, I created the output values. I created the money. Isn't that nice? So they're the dependent values. They depend, whatever my money is, depends on how many hours I work. And they're also known as the y values. All right. A lot of times we're just looking at the points and determining the y value. All right. And so it's from a set of points, we're looking at the y values and we're looking at it based on a situation. So go ahead and write all that in. Another way to look at the domain and range is in a table. So if you could, we don't have a lot of more writing here. If you could make me a little table, instead of making an XY table, make me a function table, x and f of x, all right? And write down that 10 for me that we had in the upper situation, and you made $260, right? So we input $10, and our output was $260. Lovely. That means I made $26 an hour. Now, in my table, could I have another 10 with a different amount of money? No, you make $26 an hour. That doesn't make sense. So this is why we're saying each x value has to have a unique y value. I can't repeat my x's because that wouldn't make the function or the situation true. So this is a big no-no. And this is from whenever you're looking at and determining if something's a function, we're looking to see that to make sure that the x's don't repeat. All right, and so you're going to see this. You saw it in a graph as well, but now you are looking at mappings. You will probably see some mappings, and so I want you to see there are these kind of oval shapes, and you can see that it's got an X and a Y above it. So this is just, write this down. This is the last note you're taking here, and then you're just going to make some choices on some problems. A different way to list points. A mapping is a different way to list points. And so we're not going to be freaked out when we see these blobs here. It's just showing that the pairings up of points, all right? And so this question is asking which of the following would still be a function if the point -10, -7 was added to the relation. All right, and so I'm looking for if I can still add -10 and -7. Well, if I put -10 and -7 here, you can see that my x's are going to repeat, and that is a no-no. And so this is a no. I cannot, and this is my example there, that I have a -10. So when I'm looking to decide if something's a function or would still be a function, I'm looking at only the x values, and I'm looking for repeats. And again here, nope, that is not a function if I would add the point -10, 7. Over here, there we go. There is my function there. It would still be a function if I added the point 10, -7, right? And I can put it kind of right down there. And then I'm just going to highlight here that that one definitely would not be the function. So if you could add this one little line here, the bottom, yes, still a function because the x's don't repeat. That is the one that works. This one right here. Make sure I mark it carefully. All right. All right, let's turn the page and let's just look at a few examples. All right, and so we're looking at which number is in the relation's domain. So write me two little notation here, the x and y. We always remember that x goes first and then y. That's alphabetical, but so is domain and range. So this might help you out a little bit, domain and range. So I have to look carefully at what they're asking me for because over here they're asking me about the range in number 4. So which number is in the relation's domain? And so what I do is I'm just highlighting the x's because I know domain is x. So I'm just going to highlight all the x's, boom, boom, boom. They're not asking me if it's a function or not. They're just asking me which number is in the domain. And so I start looking, and is the number 1 in those highlighted x values or domain? Nope. Is the -7? Nope. Oh, they're listed up there in the y's. 0, oh, there it is. 0 is in the domain, and so that's my answer. All right, number 4. Now this is, you got to read carefully, so we take our time. Which number is not in the range? And so I'm looking, I remember that range is y's, and so I'm looking in the y column, and I'm just looking for one of these numbers that is not in there. Well, 0's in there, -8's in there, 6 is not. 6 is my number, and I can see that -9 is in there. All right, so this is just a little practice of vocabulary, some new vocabulary, some synonyms for x and y in terms of functions. So last two problems here. Which ordered pair could be included in the relation so that it remains a function? So it has to have no repeat. So I'm looking, it's asking me about function, if it's a function or not, so I'm going to focus on the domain. That's why the note up here is written, check the domain. So these here, this which point, so I'm going to look at the x values. Would it remain a function? Is there a repeat? Well, there's a repeat there. That wouldn't keep it a function. That would make it not a function. -9. Oh, that's up there. That wouldn't work. 10. 10 would make it not a function. I can't add those points to this list or it would fail. And so -4 is not in the domain and it would still be a function if I added that. And the last one is, which of the following would no longer be a function if the point -9, 3 was added? And so again, I am going to look at each example and I'm going to look at the x's until I find an answer. So if I added this, would no longer repeat. Could I add -9, 3? Yeah, I could add -9, 3. That would still be a function, but I'm looking for the one that would fail. And so when I look to the next line, there it is. -9 is right there. I have a repeat. That would not be a function. It would no longer be a function if I added that to this list. And so this is my answer here. It's a little tricky reading carefully and reminding ourselves that x is domain, y is range, and that the x's cannot repeat. No. Thanks for listening and taking notes.